7 and welcome to our new unit on number patterns in algebra. I have here from page 368 in your textbook a visual pattern that we're going to be working with, and if it doesn't show up too well in the video, feel free to pause, turn to page 368 in Math Makes Sense grade 7 and have a look at this pattern. You'll notice it's a series of triangles in different orientations. And we can see them labeled as being the first, second, third, fourth, fifth, etc. as we go to the right. And if I were to ask you to find the ninth, I think you would find that relatively simple. You notice that the eighth is pointed to the right. And if we look at the fourth one, it is also pointed to the right. And if this is a repeating pattern that never fails to repeat in the same way, the one that follows the fourth, which points down, must also be the one that follows the eighth. And so the ninth would be pointing down. And in the same way we could work out the 10th and the 11th and the 12th, etc. But if I asked you to find the 99th term in our pattern, it might be a little daunting to have to draw out each triangle in sequence till we get up to the 99th one. So this is a review of a concept, I realize, and some of you may not need to go through this. Feel free to fast forward then. But if you're wondering how you would find the 99th, the key here is to find the core of the pattern. In other words, at what point does the pattern begin to repeat itself faithfully? And if we look carefully, we have down, to the left, up, to the right, down, to the left, up, to the right. We can see what's repeating here. This is what we call the core of the pattern. These first four terms of our pattern form the core. So what we need to do is determine the length of the core, which in this case is 4. And what we know, once we know the length of the core, is we know that every multiple of that length is going to give us a triangle that points to the right. So the core is 4 long. The first multiple of 4 is 4. And here we go, the fourth term points to the right. The next multiple of 4 is 8, and we can see that that one also points to the right. And so we know the 12th will, and the 16th, and the 20th, etc. So the trick is to find what is a multiple of 4 that gets us close to the 99th triangle. Well, one that leaps to my mind is the 100th, because 100 is a multiple of 4. And so I can say with confidence, if 100 is a multiple of 4, then the 100th term is going to be a triangle that points to the right. And if I know that, then the 99th term is the one before it. Let's look at another one that points to the right, and look at the one before it. That's a triangle that points up. And so now we can say with confidence that the 99th triangle is one that points upward. So let's move on now from a visual pattern like that, and let's turn to one that is based on just numbers. I have a few examples here for you to look at. This first sequence goes 3, 7, 11, 15, 19. And I'd like you to look at it and pause the video if you need to and figure out how this pattern is generated. Correct. We start at 3 and we add 4 each time, and so we know the next 3 would be 23, 27, 30. But once again, what if you were asked to find the 99th, way out over here, or the 200th, way out off the end of my screen, or the 1000th? You certainly would not want to be generating all the terms in between. So let's consider then what position each of these terms has in the sequence. This has position 1, then 2, then 3, 4, and 5, and so on. And if we can figure out a way to go from the term number to the term value, then way out over here on the right, we can know the term number and just generate the term value without finding all the ones in between. So that's our goal. One of the keys to doing this is to create this sort of t-table and fill in these values. And what we want to do now is figure out how can we go from the top straight to the bottom, for any given n value n being the position in the sequence, can we perform a simple operation that will move us down to the term value? Again, you might want to pause and have a look for patterns here, but I'm hoping some of you might have begun to see that if we take the term number and we multiply it by 4 and then subtract 1, we will get the values of each term. Let's test that. 3 times 4 gives 12, subtract 1 gives 11. 5 times 4 is 20, subtract 1 gives 19. Okay, we found a way that works. This will allow us to move, say, way over to the right and find our 300th term. The thing is, how do we do this without having to guess and check to find exactly how to get from the n value to the term value? Well, this is where there's a nice trick that you can employ every time. You noticed right away at the beginning that each time our gap, the amount that we're adding, is exactly 4, and that never changes. As soon as we have a gap of 4, we know right away that n times 4 is going to be part of an expression that helps us move from n to the term value. So what do I mean by that? Well, let's look at term number 3. If n is 3, 3 times 4 gives 12. That is close to this, but not quite there. In order to move from 12 to 11, I need to subtract 1. I now have an expression that moves me from my term number to my term value. Let's see how we can use this now to jump, to simply skip all the way from, say, the 5th term all the way to the 300th. It's simply a matter of substituting 300 in for the n, and we'll have our value. So let's try it. We always begin by writing the expression we developed, which looks like this. Some of you might like to write it like this, which is more typically the way mathematicians would write the expression. Both are acceptable. We then substitute in the term number that we're looking for, which in this case is 300. So I substitute that in, and then I begin to solve the expression. And so you can see that right away I know the 300th term will have a value of 1,199. It saves us a whole lot of steps in between. Let's take a moment now to consider a second one, because that might have been a lot to absorb all in one go. So let's take a look at this sequence now. 5, 8, 11, 14, 17. I think you see what's going on. Start at 5, add 3 each time. But once again, if I need to find the 1000th value or the millionth value, I don't want to be filling these in the whole way. I need a way to get from the term number, 1 or 2 or 3 or 4 or 5, from the term number to the actual term value in a single step. So let's consider the way we did it last time. We created this t-table, we put our values in, and then we said, what's the gap? Well, 3 each time. And if you have that, a gap that never changes, you have a quick way to find your expression. It seems a little odd that we're adding 3 each time here. Just as up here we added 4 each time, but ended up not adding 4 to n, but multiplying n by 4. It's going to be similar here. We're adding 3 each time. We know that n times 3 must be in our expression. Well, let's try some. When n has a value of 2, 2 times 3 is 6. That doesn't quite get me to 8. But what tweak will get me there? That's correct. Adding 2. Let's see if it works on another one. If it does, we know we've got it. So when n is 5, I want to end up with 17. So when n is 5, times 3 gives 15, add 2 gives 17, and so I think we found our expression. So let's say that we did want to find the 1000th term, way out here on our number line. Well, we always begin by writing the expression we developed. Then we substitute in the term number we're looking for, which in this case was the 1000th term. And then we solve using BEDMAS. So we have 3000 here, plus 2, and there. We've skipped ahead into the future rather than writing out all our values. We've skipped ahead to say, hey, I know that the 1000th term in my sequence will have a value of 302. And you can apply this to any number in the sequence. We could find the millionth or the billionth, and we do that very simply by writing our expression and substituting in. To recap, as briefly as I can, remember, when you have a sequence that has a constant gap, you take your n value, your term number, multiply it by the gap, and then see what tweak you have to do to make sure it lands exactly where you want it to land. We'll have exercises in classroom today that deal with this kind of sequence, and in future lessons, we'll take a look at other kinds of sequences. Feel free to rewind, look at it again, take notes, and figure it out. And in your exercises today, please have a t-table, as well as an expression, a substitution, and a solve. That's it for today. I hope your exercises go well. Bye for now, grade 7.